I'm going to introduce our second panelist, Ms. Tian. Jean joined the Jean is the director of investor relationship.
Okay. Introduce myself.
No. Let me finish my job. Director of Investor Relations of Yingli Green Energy. Jean joined Yingli Green Energy in 2006. She has engaged into the IPO of Yingli Group on New York Stock Exchange and participated into the company's offshore capital market operations. Okay, welcome, Jean.
Thanks everybody. First, I think I'm very pleased to have this chance to speak here. This is not my first time to be in Hong Kong, but this is indeed my first time to speak at this kind of forum. So, to be honest, I think it's more interesting than talking with my investor. So, please keep it secret. And just now, several professional speakers talking about from the solar industry and the solar application from the macro level and from the policy level. So I would like to drill down to the practical level from a company side to talking about how to utilize the solar power in a city. So my topic is green solar power lighten city up. Firstly, at the beginning, I want to introduce you Yingli briefly. Yingli has entered into the solar industry in 1998 and listed in NYSE in 2007. And we were the largest solar company in the world for 2012 and 2013, and we are the second large for last year. And to date, we have successfully to ship over 30 gigawatts PV modules across the world. That equaling to around 9 million, reducing 9 million tons of greenhouse gases emission. Also, we have joined into the Climate Saver program of WWF since 2013, and as the first solar company and the first Chinese company. For this program, we have set up several ambitious commitments, not including for our self-production, how to reducing our own green gas emission, but also for the utilization for our renewable energy consumptions, self-consumptions. And we, as a solar leader, we also leading to issue green production standards, which is aiming to drive the whole solar sector into more greener production. And on the right side, you can see a table that's indicating, compared to with the conventional electricity power, 1 megawatt of PV project can save those amount green gas emission. So talking about therefore, rather than a solar rather than a solar PV producer, we are more like to be called a green power solution provider, you can see those pictures that indicate how to utilize the solar projects on our rooftop of the idle lines. You can see it can be the PV modules can be installed on the rooftop of our house and on the facilities. I noticed some friend from the University of Hong Kong, so it can be also be installed on the rooftop of the teaching buildings. So now I would like to share with you some case study. The first one is about FCBN. FCBN, I think you may know this name, right? So yes, we have a very good relationship with FCBN, and we help them to set up a PV system on its training facility in Munich. And the second case study is a perfect demonstration project which can be called BIPV. And this project is the first one BIPV 5-star hotel in China. And maybe you don't know what's the BIPV. The BIPV means using the PV modules to replace the glasses on the surface of the building. So it can be used as the glass, but also it can generate the green electricity. And the third one is a new model of a glass house, which is under construction, and I think it can be complete in the middle of this year. And this is a very beautiful building, and it can be called a kind of glass house. It's used the high efficiency our high efficiency PV module products, so it can generate more green electricity. If you get any chance, you can, or you have the interest, you get any chance to Beijing, you are welcome to visit and go see our glass house. The last case study is a business model involved two parties. The party A has the idle rooftop or the idle lands and need to buy the electricity from the grid companies with a relatively high electricity price. So Part A would like to reduce its cost on the electricity. So Part B rent the idle rooftop or the land from Part A and install PV modules on top of it. Then then sell the electricity generated by the PV systems to Part A. So in this business model, you can see Part A can fully utilize its unusable resource, but also can reduce its spending on the electricity. Part B can get a stable and a very attractive investment return. So both parties can benefit from this business model. And talking back to the PV systems, now maybe you are wondering, how about the cost? To be honest, currently many regions and countries, in many markets, and currently the solar application is still depends on the government support and with the feed-in tariff subsidy. But for some areas, the solar power is already reached the grid parity, which means the cost of solar electricity can compete with the conventional electricity price. Such like about 10 states in US. So the last page. And in the past, you may think the solar application is far away from our daily life. So through my presentation, I hope your opinion about this point can be changed a little bit. And along with the technology innovations, more and more solar applications is commercialized and improved gradually. Such like you can see the solar charger, the solar power car, the solar plane. So I believe you and I will witness this good change, and the solar power lighten this city up. So that's all. Thank you.
Thank you, Tian. As she just mentioned, Yingli is the largest PV manufacturer in the world. And what she didn't mention is that Yingli is also a pioneer of emission reduction in the industry. Yingli joined WWF's Climate Saver program in early 2013, and they are doing a clean manufacturing standard for the PV sector in China. Let me introduce our third panelist, Professor Johnny Chen. Johnny is currently Chair Professor of Atmospheric Science, Dean of School of Energy and the Environment, and Director of the Guy Carpenter Asia Pacific Climate Impact Center at the City University of Hong Kong. He is a fellow of the American Meteorological Society and an honorary fellow of the Energy Institute UK. Johnny published over 170 international journal articles. Let's welcome Johnny.
Okay, thank you very much. I'm not an energy expert. I was asked to talk about this because I'm wearing my hat as the Dean of the School of Energy and Environment at CTU. As you can you hear that I'm actually a climate scientist, but now our first speaker said renewable energy has nothing to do with climate change. So, but anyway, so what I want to do in the next few minutes, I was told that I can only have 6 slides, so now I have 7, besides this one. So what I'd like to tell you a little bit is my thinking is that not only in Hong Kong but also in all the built-up areas, especially in Asia, how we can generate more renewable energy. Now we heard this morning that we heard about solar, we heard about wind, but there are other sources that have not been really discussed. So maybe we can speak a little bit more about that. So of course we all know that there are all these different types of renewable energy sources, and I don't need to go into that too much. And of course we've heard the BIPV just now, was discussed about the Yingli experience, and of course there are different types of building integrated PVs, including on the walls and on the sides, and in the atrium, and also in bus stops that we have not thought about too much. We can do this, and it was really exciting that last week I was in Australia visiting the University of Technology Sydney, and they built something like this. They call this an urban power plant. And I think this is something that we should all think about in cities around the world. So in an urban power plant, you have all sorts of things that are available there. So you have they have a wind turbine there. They have, I actually put them in here. So they have a wind turbine, they have solar PV, they have solar collectors that run, and in fact, it's the cheapest you can do is that they actually run water through this pipe. So instead of different other materials, because water is cheaper, so they're going to run this and heat it up to 200 degrees centigrade. And then they also have solar water heaters. So now this type of rooftop is not atypical in many of our buildings in Hong Kong. And with this type of setup that they have, they're actually generating about 450 megawatts of electricity, and that constitutes about 10 to 15% of the energy consumption in this building, which is about a 12-story building. Okay, so this is something that we should be thinking about on the rooftops of many of our buildings in Hong Kong that we should do. I think this is exciting to me when I saw them this setup last week. But besides these two, we can also think about wind turbines. Now we have this wind turbine here, but of course this is you can only set up one or two. But something that's interesting is that we can do something else. It's what we call micro wind turbines, and they're very small, only 250 millimeters in diameter. So they're designed for low wind speed, suitable for urban environment, flexible modular design, easy to install and maintain, and also low cost for mass production. And you can put them like this with different colors. And so you can put your company logo on there. So you have your company logo there. So you can actually do. I mean, this is what's done in Hong Kong actually. So you can do this in all your buildings out here, and in fact you can put this in many of the buildings on the top of the buildings in Hong Kong. So this is something that we can think about in urban settings. Every building you can do something like this instead of the LED lights that you put up. In fact, you put on the LEDs at night, and in the daytime you have these turbines. Now, something else that have not been talked about too much is about waste to energy, and in particular food waste to energy. And we all know that in Hong Kong people eat so much, but they don't eat all of them, and that's the biggest problem. And so we have come up with, of course, this is a method that has been done, and then the government is already trying to set up something like this in Lantau Island, but I think this is wrong. And the reason why it's wrong is because you collect all this food waste from all over Hong Kong, and you ship it over to Lantau Island, and then you generate electricity there, which nobody uses there. So you have to transmit the electricity back to the airport or whatever. So throughout this process, there's so much loss in terms of energy. There's so much increase in the carbon footprint. However, what we are proposing here is that you do a local generation. So every housing estate, every commercial building that has food outlets and so on, you can do something like this. You can build a small scale processing plant that can convert all your food waste to energy, either through methane, you convert to methane, or you can also create electricity from that. So we're doing a pilot plant right now with hopefully the Jockey Club, and to do something like this. And I think this type of pilot plants can be installed in every housing complex in Hong Kong. Now, something also very interesting that we are working on right now. One is tidal power. Now, the tidal current in Hong Kong is not very strong. However, we have lots of water. All over, we're surrounded by water all three sides. So we are building a prototype here, which is a a very small turbine, not very big, but the idea is that you can put them all together just like the micro wind turbines. If you can put a whole series of these micro turbines, it will be, you can generate electricity. And the beauty of this is because in most places when they think about tidal energy, they think about very strong currents. But strong currents have a big problem because the engineering design is very complicated. It costs a lot, and that's why even today, the amount of electricity, there is really very, very few operating plants in tidal energy because of the cost. However, if we can design small plants like this, small turbines like this, we can generate electricity on a local level, and then therefore you can have, everywhere you have water, you can do this. In fact, tidal energy is the only renewable energy in this world that's predictable. Okay, so that's something that we need to think about. And last but not least, wave power. We have designed something like this. This is a wave power that goes, it oscillates up and down because of the waves, and you can actually generate electricity from that. And many of the people doing wave power have looking at waves, huge waves, many kilometers offshore, and then there's again the problem that you need to bring the electricity back to shore. But if you look outside, hydrofoils go back and forth every minute. So you have lots of waves, and thanks to the bad design of Hong Kong engineers, the seawalls in the harbor is vertical. So you have all these waves bouncing back and forth, and if you put wave devices there, you can actually tap wave energy in the harbor, and you only have a few meters to go to get electricity. Okay, so summarize, renewable energies are available, we just have not been innovative enough, and or willing to put in the investment. And very importantly, local and distributed generation can produce an appreciable amount of renewable energy. With microgrids, such generation can be detached, actually can be detached from the grid. So I'll stop here. Thank you very much.
Thank you, Professor. Professor said he was not an energy expert, but showed us a lot of very innovative renewable energy solutions.